Hello and welcome back to the channel. In this video I'm going to be making a controllable desktop laser turret, and to do that I'm going to be basing the project around this, the Arduino Uno. Now an Arduino is a microcontroller, and what that means is you can connect to it a bunch of input devices, so maybe temp sensors, light sensors, controllers, connect up a bunch of output devices, so lights, motors, MOSFETs, that kind of thing. Then you can upload custom code to the board to describe how all of these inputs and outputs should interact with one another. So, what else are we going to need? First, we're going to need an input device, and I've got this old gamepad that I'm willing to hack apart and sacrifice. Then we're going to need to build the turret itself, and for this I've got two servo motors, one for up and down and the other for left and right. I did originally plan to design and 3D print the plastic parts to assemble this thing. But to be honest, I'm terrible at 3D printing, and I found an eBay listing with two servos and all the plastics I need for about a tenner, so I went with that instead. So, the eBay parts were okay, the fit was decent enough, though there were no assembly instructions. I just had to look at the pictures on the eBay listing and kind of figure it out for myself. It was fine though, certainly less painful than designing and printing the parts on my own. Once it was assembled, I added some header pins to the servo leads and attached them to the breadboard. Each servo has 3 wires coming from it, plus 5 volts, ground and a signal wire. We can connect plus 5 and ground directly to the power pins from the Arduino and add a capacitor across just to smooth out any power spikes. The third wire is signal, which we will connect to pin 8 of the Arduino. This pin is labelled PWM for pulse width modulation. And the way these servos work is the length of the pulse they receive determines the angle they move to, which means when we have two servos set up like this, we can very precisely control their angles and ultimately what the turret is aiming at. Let's look at some code now. The Arduino uses its own language that's like a stripped down version of C, and one cool thing that it has is the servo library. Here I've created a simple sketch that declares a servo, attaches it to pin 8 and then writes the angle I want to move the servo to. So here I'm setting it to 0, its start point. Once I upload the sketch to the board, it should move the servo. Now let's send a fresh sketch that moves it to 180 degrees. Okay, so I've repeated the circuitry for the second servo and have a new sketch that will run both at the same time to demo the full range of movement, and this just uses a for loop to step through all of the possible angles. Now we have the servos sorted, we need to set up our input device. I think what I'm going to do is open up this controller and solder connections directly to one of the sticks and a couple of the buttons and make a breakout cable. I think this calls for a montage. Okay, so that's the controller all wired up. So the next stage is to connect it to the Arduino and see if we can read the inputs. So if you think about an analog stick on a controller, all it is a pair of variable resistors with one reading the X position of the stick and the other reading the Y position. So what I've done is send 5 volt from the Arduino to one side of the resistors, ground to the other, and the middle pin gets connected to one of the analog pins of the Arduino where we can read off the voltage and hopefully process those voltages into movements of the turret. So next we want to convert those signals into something that can drive the two servos, and I'll let you into a little secret here. I really don't know Arduino code very well at all. I can follow it because I know JavaScript, but for projects like this, I'm happy to let the AI do the heavy lifting. Okay, now we've got working servos, we need to look at the laser, but I want to talk a little bit first about laser safety. So I bought this laser from eBay for a few pounds. It's a 5 milliwatt laser pointer. It's low power, it's pretty safe to use. I also bought this laser from eBay for a few pounds. Advertised as 10 milliwatt, but if you look at the label, 100 milliwatts, class 3B laser device. Now it's pretty common to find these higher powered lasers for sale listed as low power devices. But the difference is if you get this in your eye, it's likely to cause you permanent eye damage. Even reflected or scattered laser light from one of these can be quite harmful. I might do a video in future about the damage this can do to a camera sensor, but that'll have to wait until I've got some decent eye protection and a bit of a safer setup. In the meantime, this one's staying safely in the drawer. Right, so I've soldered some breakout wires to the laser driver so I can send it power directly, and I'm going to do that via a transistor, because although my Arduino pins can give it enough voltage, they can't provide the current needed to power even a small laser like this. So the transistor can switch on and off power directly from the main 5-volt supply. To switch it on and off, I've wired in the clicker from the second stick of the controller as a trigger, so now I need to update my sketch to handle switching the laser on and off. Okay, so to update this sketch, I'm just going to let the AI do it again because it's just quicker than me. So here we go. Okay, so it looks like the sketch is working correctly. I think it's time for a field test. Okay, so test 1, epic fail. I've burnt out the laser. So I've ordered another one from eBay and I'll pick this up in a couple of days. So there we go, hours of design, engineering and coding to make a hugely elaborate cat toy. Seriously though, this has been a really fun project and I learnt a lot about Arduino on the way. There is a part 2 to this video I've got in mind, so keep your eyes peeled for that coming up soon. Until then, thanks for watching, please like and subscribe and I'll see you in the next video.